All right, guys, new topic, and it's going to tie in a bunch of what we've been doing over the past few days and actually reaching into the previous week. We've actually done this a little bit, solving quadratics with the square root property. But now a lot of the stuff we've done with roots is going to come into play here. So the general question is, how do you solve an equation like this? X squared equals 81. And take you back to basic algebra and look at a question like this. X plus 4 equals 7. How do you solve that? Well, what's being done to x is plus 4, so you do the opposite, which is minus 4. Do that on both sides, and of course you get your answer. So you do the opposite, you do it to both sides. Same thing on a square root property. What's being done to x? It's being squared. What's the opposite of squaring? Square rooting. You square root both sides. A square and a square root cancel out. We did that in the previous lesson. That gives you x. What's the square root of 81? 9. And you're like, oh, there's my answer. I'm done. But not exactly. Yes, 9 works. 9 squared equals 81. However, negative 9 squared also equals 81. When you square a negative, negative 9 times negative 9, it turns positive and you get positive 81. So it turns out that yes, 9 is an answer, but it's not the answer. Both positive 9 and negative 9 are answers. So we say the solution is plus or minus 9. Now you can write it this way, or you can say x equals negative 9, comma, positive 9, and say there's two answers, or you might see x equals negative 9, comma, x equals positive 9. A few different ways to write the answer, but that's the point, the whole point. When you square root both sides of an equation, that's called the square root property. You have to put a plus minus on your answer. It gets more complicated than that as we go, as math always seems to do, but that's the heart of it right there. So I'm going to work through several examples. They're going to start really easy, and then they'll get more and more numbers and steps thrown in there, and then we'll get to some negatives, which remember, if you square root a negative, you get the imaginary number. That's a thing. So yeah, let's do this. Number 2, very simple. N squared equals 49, so you square root both sides. The square root of 9 is 7. I'm sorry, the square root of 49 is 7, but with the square root property, you could get positive 7 or negative 7. Let's go check and see if that's right. Oops, I didn't mean to do that. So number 2, negative 7 and positive 7 right there. Okay, maybe I better get, oops, too far. Better get in the habit of writing my answer like this. Nah, I hate making those little brackets. They're such a pain. I think if I write the answer like this, you'll be good enough. It'll be the same. All right, number 4. So if we want to solve for k, we have 25 times k squared. First thing we're going to do, divide both sides by 25. Now, 25 won't divide into 16. You could grab a calculator and get a decimal, but there's no need for that. Just leave it 16/25. You'll see why in a minute. Because the next step will be square root both sides. And then we'll get a plus minus, right? Anytime you square root, you get a plus minus. And now just do the square root. What's the square root of 16 and what's the square root of 25? Square root of 16 is 4. Square root of 25 is 5. So the answer is either 4/5 or negative 4/5. Let's check number 4 and make sure I did it right. 4/5 and negative 4/5. Right on. Let's do number 6. Okay. Subtract 7 on both sides. K squared equals 32 minus 7 is 25. Isolate k. We need to cancel out the square, so square root. The square root property says you must put a plus minus on your answer, and the square root of 25 is 5. So the answer is positive 5 or negative 5. Let's see number 6 if that is right, and it is. Check out number 8. So okay, we have a multi-step problem here. There's several steps we need to do to make this work. First, add 7 to both sides. 4r squared equals 9. Then divide by 4 on each side. R squared equals 9/4. You can't really simplify 9/4 or work it out. That's fine. Leave it a fraction. Simply square root both sides to cancel out the square. put a plus minus down. That needs to be automatic. As you do the square root property, you need to get really familiar and comfortable with writing plus minus down at this point. And then do the square root. Square root of 9 is 3 over the square root of 4, which is 2. So our answer is 3/2 and -3/2. Let's see if that is right for number 8. I know it is, but you know, there. Okay, so the first page should be fairly simple. When you see 3 pages of work, you might feel discouraged and bummed out, but to know that one of the pages at least is simple and straightforward, usually a good thing. All right, let's look at number 10. Okay, start by adding 5 to both sides. 5a squared equals 380 plus 5 is 385. Divide both sides by 5. A squared equals, now 385 is divisible by 5. You know that if a number ends in 5, it can be divided by 5. Although I don't feel like trying to work this out in my head. I'm just not feeling it. So 385 divided by 5, 77. Oop. Get rid of that. Come on. Come on. Golly. Okay. All right, so a squared equals 77. That just looks goofy. Square root both sides to cancel out the square. Automatically put down a plus minus. And then 77. Can you square root 77? No, it's not a perfect square. Can I simplify 77? No, it only breaks down into 7 and 11. We need pairs of things to simplify. So, gosh darn it. So it looks like our answer is positive square root of 77 and negative square root of 77. See if that's right for number 10. And there it is. Sweet. Not so bad. Number 12. All right, I'm going to subtract 5 on both sides. 6x squared equals 162. Divide by 6. Shouldn't have got rid of that calculator. 162 divided by 6 is 27. Oh, come on, go away. Oh, gosh. Right. You guys, my struggle, I tell you. Okay. So I get x squared equals 27. Of course, now I have to square root both sides to cancel that out. I automatically put a plus minus, and I'm facing the square root of 27. But can that be simplified? Well, 27 is 3 times 9, which is 3 times 3. I do have a pair of 3's. So that's 3 squared, and then an extra 3. So the one with a square, when you square root it, simplifies out. You get plus minus 3. The one without a square stays under the radical bar. So our answers work out to be positive 3 square root of 3 and negative 3 square root of 3. Let's check number 12 and make sure I didn't mess anything up. There are a lot of steps there, and there it is. Got it? So same idea, some basic math first, minus 5, divide by 6. Yeah, I used a calculator, whatever. Square root both sides, put down your plus minus, of course. That's something you got to do. And then simplify the radical. So we've been covering that the last couple of days. You're expected to know how to do that now. Let's look at 14. Well, it looks pretty straightforward. If I want to solve for n, I just need to square root both sides, cancel out that square. But I get n equals the square root of negative 49. So here's how you want to look at this. The square root of negative 49. Negative 49, well, okay, you got to have the plus minus, let that be said. Negative 49 is really negative 1 times positive 49, right? So you could think of this as the square root of negative 1 times the square root of 49. What is the square root of negative 1? What is special about that? If you didn't watch the earlier videos, you're going to need to go back and watch the one on complex numbers. The square root of negative 1 is I, the imaginary number. So your final answer here is plus or minus I, square root of 49. What's the square root of 49? 7. Plus or minus I7. Okay, that's not really the way it's written. It's written 7i, not I7, just like variables. So 7i, so positive 7i and negative 7i are the two answers for number 49. Oh, my dogs. I hope you can't hear them in the background because they are going nuts. Someone's at the door, I think. All right, number 16, same kind of an idea. We need to solve for v, so I have to square root both sides. It cancels out. The square root of negative 68. Well, we're automatically going to need a plus minus. Square root of negative 68 is like negative 1 times positive 68, right? So square root of negative 1, square root of 68. The square root of negative 1 is I. The square root of 68 is not a perfect square, so it won't just perfectly simplify. Let's go off to the side and look at a factor tree and see if it'll simplify at all. So that's what? 2 times 34. 34 is an even number, so you divide it by 2, and I believe that's 2 times 17. 17 does not break down. So we do have a pair of 2's and a 17. The square root and the one with a square simplify, so plus minus I. We can simplify out that 2, but the 17 is going to stay radical. So plus or minus I times 2 square root of 17. The way to write your final answer is positive 2I square root of 17 negative 2I square root of 17. So that one was complicated. Well, first I got to see if it's right. And yes, it is correct. So we had to use the square root method, square root both sides, put a plus minus on it. Then we square rooted a negative, which meant we would have I in the answer. And then the radical itself simplified, so we had to do that. So this had several concepts all in one problem. The square root property, the imaginary number, and simplifying a square root or simplifying a radical. 16 is really complicated. Your 15 is probably going to be about like that. So this is one to really test yourself. If you can do 15, you're doing really good. If you can't, that's where you need to contact me and ask for help. Okay, number 18. So how do we do this? Well, let's add 4 to both sides. We get n squared equals negative 16 plus 4 is negative 12. Square root both sides. N equals. Put down the plus minus automatically. All right, here's the next thing I'm going to do to try to save some work. So hopefully you get to these hard problems, you don't have to do so much. Whenever you square root a negative, you're always going to get this negative 1, which is always going to turn into I. So maybe we can just condense things a little bit and say it this way. If you ever face a point where you're square rooting a negative, just go ahead and write down I, and then get rid of the negative and keep working out the rest of the problem. So the fact that we are facing the square root of a negative means that we're going to have I in the answer anyway. Let's just cut to the chase and do that. We'll put I in the answer. Now all we have to do is look at the square root of 12. Well, that's 2 times 6, 2 times 3. We got a pair of 2's there. So the one with a square root simplifies, the one without a square doesn't. The one with a square simplifies, the one without a square doesn't. So this works out to be plus or minus I times 2 square root of 3. So final answer, positive 2I radical 3, negative 2I radical 3. Again, I times 2, just switch them around, call it 2I. And that should be the answer to number 18. Let me double check and make sure. There it is. So we're doing some complicated math here. Look at number 20. All right, we want to solve this equation. Isolate p. So p is multiplied by negative 2, so I'm going to have to divide both sides by negative 2. 140 divided by negative 2 is negative 70. To isolate p, I have to square root both sides. That gives me p equals plus minus, right? Square root property tells me to automatically put down a plus minus. The square root of a negative tells me that I'm going to automatically have an I in my answer, an imaginary answer. The square root of 70, I may need to see if I can simplify that. That's what, 10 times 7, 2 times 5. No, that does not break down or simplify at all. So my answer is should be just positive I square root 70, negative I square root 70. And that should be it for number 20. And it is. Good. 2 more. All right. Number 22. Subtract 5 on both sides. 6r equals negative 12. Right? Yeah. R squared, that's what it is. Divide both sides by 6. R squared equals negative 2. Square root both sides. Plus minus. You always got to put a plus minus whenever you do the square root. Do I sound like a broken record? Like I'm saying the same thing over and over again? Like I'm repeating myself? Like I'm being redundant? Yes. Put a plus minus on your answer. Square root of negative, automatically going to have I in the answer. If you need to, you could always rewrite it like this. And then change that into I. If you need to write every step, that's fine. But if you want to streamline things, anytime you square root a negative, you're going to put I in your answer. And then finally, that leaves us with square root of 2. You cannot simplify square root of 2. You cannot make a factor tree out of it. So, oh, sorry, I don't want to circle that. Positive I square root of 2, negative I square root of 2. That should be the answers to number 22, and it is. All right, last couple problems look like fractions. Let's see what kind of trouble we're about to get into. Okay, number 24. First, we'll add 3 to both sides. 10x squared equals negative 175. Next, divide both sides by 10. X squared equals negative. Now, 175 you cannot divide by 10, but one ends in 5, one ends in a 0. You can reduce them both by 5. So negative, you know what, let's do calculator. Here, let me show you this fun little trick. Maybe I've shown you before. I can just do negative 175 over 10, and yeah, it gives me the decimal, but if I hit, you see the little circle up there, like it's blinking on and off? So if you hit that button, it turns it into a fraction for you, 35 over 2. So a little tip if you're using Desmos and you don't want to have to deal with fractions, there. Now we square root both sides. That isolates x. The square root property tells us to put a plus minus down. We're square rooting a negative. What does that mean? Square root of negative means we're going to have I in the answer. Square root of 35 over 2 is the square root of 35 over the square root of 2. In a previous lesson, we talked about how you are not allowed to have a square root in the bottom of a fraction. In fact, if we look down at the answer, there is no square root in the bottom of those fractions. So what's up with that? Well, hooray for us, we get to do the rationalizing trick. That's where you multiply by the square root of 2 over the square root of 2. So, we still have a plus minus. We still have I. When we do the fractions, multiply top times top. Square root of 35 times square root of 2 is the square root of 70. Bottom times bottom, square root of 2 times square root of 2 is square root of 4. And can you do the square root of 4? Yes, you can. So it's plus or minus I, square root of 70 over 2. Alternatively, this could be written as plus or minus I square root of 70 all over 2. Those are equivalent. They're both the same. It doesn't matter which way you write it. They're both right. And then finally, you can split your answer. So you got I square root of 70 over 2 and negative I square root of 70 over 2. So that had better be, and it is, the answer. So 24, quite a chore. Hey, that rhymed. Number 23 might also be a chore for you, just about the same. Looks like the number's a little smaller, but yeah, it's going to be work. So when you do 23, look back at 24 for help. Or contact me if you need help. I will do a Google Meet and work with you, and we can get through this. All right, until I talk to you.